Hello friends, in this video you will learn how to extract the digits from an integer. One question comes in ICC section B where you need to extract the digit of the number and manipulate it in different ways to sort the given problem. Watch this video thoroughly and understand the process of extracting digit and working with it. Extracting digits of a number is very simple. When you divide a number by 10, the remainder is the digit in the units place. You got your digit. Now, if you perform integer division on the number by 10, it will truncate the number by removing the digit you just extracted. You need to repeat these two steps till the number turns 0. To extract all the digits of the number. Let us apply this on the integer 1 to 3 and see if we can extract 1, 2 and 3 from it or not. Just keep in mind two things. Number mod 10 will extract the digit at units place. Suppose the number is 1 to 3 mod 10. So it will take out the last digit, that is 3. And step 2 is number divided by 10. You're doing integer division, so it will truncate the last digit. 1 to 3 divided by 10 will give you 12. So these two things you have to keep in mind when you are working with digits. So let us take one example, 1, 2, 3. On the screen you can see that we are dividing 1, 2, 3 by 10. So if you see the division part, the quotient is 12 and the last digit has come out as a remainder. Now with this quotient you will work again, because you have to work till the number turns 0. 12 divided by 10. 10 ones are 10, 2 is the remainder. So you see 12, the last digit is 2. So if you do 12 mod 10, the last digit will come out. Now the remaining number is what? 1. 1 divided by 10. 1 zeros are 0, so the last digit has come out 1 and the quotient is right now 0. Now this process ends here. Okay, so you will start with a number and you will carry on till it turns 0. And how to extract the digit? It is mod 10. And how to truncate the digit? It is divided by 10. Keep these two things in mind. Now let us proceed further. Now some programs that you can do with digit separation. Few I have given, but you can do lot many. If you get the concept, you can just do any program that is given on digit separation. The first program that we can do is what? Number of digits in a number that you have entered. Then you can do what? You can enter a number and print the digits. You can enter a number, you can reverse it. Suppose if it is 1 to 3, so reverse number would be 3 to 1. You can enter a number and can check whether it is Armstrong number or not. The logic, for Armstrong, Palindromic or any other kind of number, the logic will be given and according to that you have to do the program. Okay, so you can do Armstrong number, you can also do palindromic number or not with digit separation. Many such programs can be coded using this digit separation concept. Let us code and execute the above programs using BlueJ. Okay, this I have already coded. Just to save time, I have taken screenshot and here you have in the slide. So you see this coding part, public class digit count, and you're passing an integer. This is the number you're going to work with. Suppose the number is 1 2 3. Initially you're counting digits, so I've taken a variable called digit which will count how many digits are there. Okay, so for int I is equal to n, so I would be initially 1 2 3. Is 1 2 3 greater than 0? Yes. So digit plus plus means digit is equal to digit plus 1. Digit was initially 0, 0 plus 1 is 1. Now from here you go to this part. I is equal to I divided by 10. I told you I was 1 2 3 divided by 10 means the last digit will be truncated. 3 will go and 12 will remain. From here you will go to the condition again. 12 greater than 0? Yes. So digit plus plus, it was 1, it would be 2. Now from here you go back here. From 12 it will strike off what? The last digit. 1 will remain. It will again go to the condition. 1 greater than 0? Yes. So digit was last time 2, 2 plus 1 is 3, and here you go 1 divided by 10. The quotient will be 0 and the remainder would be 1. So quotient is what? 0. Is 0 greater than 0? No. So the condition is false, coming out of the loop, and it is printing entered number is n and digit count is this. So if you enter 1 2 3, you will get this output. Entered number is 1 2 3, digit count is 3. I hope you have understood this program. Now let us do the second program. Print the digits of the entered number. The same logic, you're entering a number, and then this time this digit will extract and keep the digits in it, right? So initially you have 1 2 3. 1 2 3 is greater than 0. Yes. So you extract the last digit 3 and you print it, and this way you will print all the digits of the number, right? And when the number turns 0, you will come out of the program. If you enter 1 2 3, it will be printed what? Last digit, you see, 3 2 and 1. I hope you are understanding. Okay, now this is actually a program for reversing a number. Same logic, here and there you have to change. So you're entering a number, and then initially digit is 0 and reverse. I would like to reverse a number. For that I've taken a variable rev which is also 0. Initially I is 1 2 3. 1 2 3 is greater than 0. Yes. So you're extracting the digit 3 and keeping it in digit variable, right? Rev is equal to rev into 10 plus digit. Rev initially was 0. 0 into 10 would be, because the precedence of into is more than plus, so into part will work first. So 3 into 10, 30 plus, rev was 0. 0 into 10 is 0 plus digit was 3. So in rev you have 3 now. Please keep in mind. Now when you go back here, 3 goes, 12 remains. 12 greater than 0. Now what digit will come out? 2. Last time you had what in rev? 3. 3 into 10 is 30. 30 plus digit is what? 2. 32. And this way, if you do the dry run, you will see the number that you have entered is getting reversed. Okay. So when you come out of the loop, you're printing the original number is this and the reverse number is this. If you enter 1 2 3, this is the output. Original number is 1 2 3 and reverse number is 3 2 1. Okay, now next program is to check whether a number entered is palindrome or not. Palindromic number is such a number like 11. If you read from left to right, 11 1 1, and this side from right to left it is 1 1, 11 only. 1 to 1. If you read from right, it is also 1 to 1. 1 0 0 1. and if you read from right to left, 1001 only. So if you read from left to right or right to left, and if the number is the same, then it is a palindromic number or a palindrome. So for that you have to write a code where you need digit separation concept. You are entering a number, okay? So these are the two variables I need. Initially I is 123, 123 greater than 0, yes. You are extracting the digit, okay? And you are reversing it. You know, it is actually the same thing that you have done for reversing. This logic will remain the same, right? Now when you come out of the loop, you will have to give a checking. If the entered number is equal to the reverse number, if it matches, then you will print the number that you have entered is palindrome, else you will print this. So try this program, run the program, try to give 11, 121 or 1001, and you see the output what it is giving. And also try a number which is not a palindrome. Try to enter 123. It will give you 123 is not a palindrome. I hope you have understood what is a palindrome and how to write a Java program for it. Now let us see what about Armstrong number. 153 is an Armstrong number. Why? Because if you extract the digit, okay, and if you cube it and then if you add them, it should give the original number. For example, from 153, 3 will be extracted, and if you cube it, it will give you 27. You store it, you accumulate it in a variable called sum, right? Then 3 will go, 5 will come out. If you cube it, it will give you 125. With 27 you add this number. Then you strike off 5, what the number remains? 1. You will extract it, cube it, it will give you 1 only. And you add this with the accumulated number, that is sum. If so, 153 is the number you have entered, and after doing this logic you will get only 153. So 153 is an Armstrong number. Now let us see the code. You have entered the number. I need a variable for extracting digit, for calculating the cube, and this is my accumulator. All numbers that I am doing the cube, I'm storing it in sum. So this is the logic. You are taking out the last digit, finding the cube, and then storing it in sum. Last digit goes with the remaining number. You do the same process. Outside the loop, what you give? If the number that you have entered is equal to sum, then it is an Armstrong number, otherwise not. So if you enter 153, it will show you what? 153 is an Armstrong number. Try to give another number which will give you whatever number you enter is not an Armstrong number. Okay, thank you so much for watching this video. We'll be back soon with another interesting video on ICC Class 10 topic. Keep learning from E-SHIKSHA. Thank you.